Hi, we're Team Down. Welcome to our report on how different spoilers affect the performance of the car.
Over the years, a wide variety of car spoilers have been implemented to increase the performance over motorsport and events, and even included into day-to-day life. The creation of the spoiler was designed to generate downforce and diffuse undesirable airflow over vehicles. Before the addition of spoilers was introduced, the only thing that kept the car to the road was the weight alone. So, the design purpose of the spoiler is to keep the car from oversteering at high speed and to overall give the driver better control of the vehicle and reduce rear lift and increase traction on the road.
There will be 3 spoilers. The first one was the GT spoiler, the second one was the whale tail, and the pedestal spoiler. There were 2 bolts in the rear of the car to adjust the angle of the spoilers. We wanted to do 3 degrees at 10 degrees and 0 degrees and minus 10 degrees.
This is the subsonic wind tunnel that we used for our experiment. We made sure that the angle was at 0 degrees for our car. We mounted our car with the different spoilers on this rod, and then we inserted it into the test area and made sure that it was at a 0 degree angle. Once we had our car mounted and inserted into the test area, we sealed the window tightly and inserted this rod towards the rear end of the car to make sure that the airflow would be constant throughout the whole car. Accurate results, we made sure that we zeroed and reset the instrument unit at the start of each test. We did each test for each spoiler twice to make sure that we had reliable results. To make sure that there were no interruptions with the airflow, we made sure that there was no one or any objects in front of the tunnel.
There's only a small difference in the results between spoilers as we expected. This was due to the size of the car and the spoilers. The whale tail had the largest downforce and also the most drag. The pedestal and GT wing had very similar downforce and drag, each having only a small difference from the results of the car with no spoiler attached. Our results show that the whale tail will be the spoiler best in terms of performance, as it has the most downforce, giving the car the best traction on the road. We've attributed these results to the whale tail being mounted the best out of all the spoilers, which has given us the most significant results. The other spoilers were too small to give any significant results.
So what went wrong? After consulting lab technicians, we found out that it would be too expensive to 3D print the car, so we had to purchase a model. During the drilling of the car, it split due to being hollow, so our initial plan of using brackets would not work. Down to this, we had to scrap our idea of changing the spoiler angle. Our backup plan for that was putting legs onto the spoilers, but this also failed due to the size of them being too small for successful 3D printing, which means we had to resort to using sticky pads.
In our opinion, we believe that there are multiple reasons why our results are not reliable, and to rectify it, we would change a couple of things when repeating. The speed of the wind tunnel is not fast enough, as the spoilers doesn't really make a difference unless it is performing in a high speed at least about 65 miles per hour or more. In addition to that, the size is too small and the spoilers are not installed properly onto the car as we only used double-sided sticky pad. We were not able to get expected results as we could not produce an accurate drag lift coefficient value. This meant we had no value to compare against.